Chapter 7 Databases in Applications. Learning Objective. After studying this chapter, you should be able to concisely define each of the following key terminology and explain the three components of client-server system: data representation services, processing services, and storage services. Distinguish between two-tier and three-tier architecture. Describe the key component of the web application and their information flow between the various components. Describe how to connect to database in a three-tier web application using Java, JSP, and Python. Understand notation of transaction integrity. Compare optimistic and pessimistic system of concurrency control. Understand the basics of application security. Client-server architecture. Client-server architecture can be distinguished by how application logic components are distributed across client and servers. There are three components of application logic. The first is the input-output or presentation logic component. This component is responsible for formatting and representing data on the user screen or other output device, and for managing user input from a keyboard or other input device, such as your phone or tablet screen. Presentation logic, sync web browser, reside on the client and is the mechanism with which the user interacts with the system. The second component is the processing logic. This handles data processing logic, business rule logic, and data management logic. Data processing logic includes such activity as data validation and identification of processing errors. Business rules that have not been implemented at the database management system level may be coded in the processing component. Data management logic identifies the data necessary for processing the transaction or query. Processing logic resides on both the client and server. The third component is storage logic, the component responsible for data storage and retrieval from the physical storage devices associated with the application. Storage logic usually resides on the database server, close to the physical location of the data. Activity of a database management system occurs in the storage logic component. For example, data integrity control activity such as content checking are physically placed there. Trigger, which will always fire when appropriate conditions are met, are associated with init, modify, update, and delete command, and they are also placed on the database server as are stored procedure. Network client-server architecture is the network component model. Process distinguished between client and server. So client workstation, personal computer, smartphone, tablet that requests and uses a service. Server, powerful computer, personal computer, mini computer, mainframe that provide a service. For database management system, server is a database server. for the internet server is a web server. Client-server architecture are normally categorized into three types: 2, 3, or n-tier architecture. So figure 7-1, application logic component. Graphical user interface through a browse. Presentation logic, input-output logic. And then procedure function program, processing logic, input-output processing, business rule, data management, database management system activity, storage logic, data storage, and retrieval. As you can see here, there are three main layers in the application. They serve different purposes. The presentation layer is one the user directly interact with. The processing logic involves the software doing all the computation for the application, and the storage logic involves the activity of the database management system. Different type of client-server system will distribute these three in different ways. Application partitioning. The flexibility inherent in client-server architecture offers organization the possibility of tailoring their configuration to fit their particular processing need. Application partitioning helps in this tailoring. Figure 7-2a. In the textbook, depict three commonly found configuration of two-tier system based on the placement of the processing logic. In the PET client, the application processing occurs entirely on the client, whereas the thin client, this processing occurs primarily on the server. In the distributed example, application processing is partitioned between the client and server. Figure 7-2b presents the typical setup of three-tier architecture. This type of architecture are most prevalent in web-based systems. As in two-tier systems, some processing logic could be placed on the client if desired. For a typical client in a web-enabled client-server environment will be thin client using a browser or smartphone application for its presentation logic. The middle tier are typically coded in a portable language such as C#, Java, or Python, PHP. The flexibility and easier manageability of the n-tier approach account for its increasing popularity in spite of the increased complexity of managing the communication among the tier. The application partitioning places portion of the application code in different locations. Client versus server after it is written. The advantage, improved performance. Second, improved interoperability. Third, balanced workload. We are going to see different type of application partitioning. This involves the distributing the presentation, processing, and storage logic to different computers in the client-server network. Of course, presentation is always at the client. PET versus thin client. PET client. A PET client personal computer that is responsible for processing presentation logic, extensive application, and business rule logic, and many database management system function. Thin client, an application where the client accessing the application primarily provide the user interfaces and some application processing, usually with no or limited local data storage. Figures 7-2 Local Logic Distribution. Two-tier client-server environment. Processing logic could be at client, fat client, server, thin client, or both. Distributed environment. So local area network are typically implemented as a two-tier system. Here, the presentation layer always does presentation logic, and the server always does storage logic. Processing logic could take place in either. This is one you are using when you walk within an office's local network or your school's computer lab. So you can see this figure, and then, three-tier client-server architecture. Figure 72, common logic distribution. B, three-tier and n-tier client-server environment processing logic will be at application server or web server. So this is how it's done on the web. There are at least three tiers within each tier doing one of the three logic. The client is you on your personal computer or mobile device. Application logic take place on the application server, and the database management server is on the database server. We'll see in later slide some code you will typically see in application logic. Notice that sometimes the processing logic is split. The underlying business logic is done on one server, and the control of internet processing is done on the web server. A database server. This server hosts the storage logic for the application and hosts the database management system. You have read about many of them, including Oracle, Microsoft SQL Server, Informix Sybase, Database 2, Microsoft Access, and MySQL. This database management system may reside either on a separate machine or on the same machine as the web server. A web server. The web server provides the basic functionality needed to receive and respond to requests from browser client. These requests use hypertext markup language, so HTTP or HTTPS as a protocol. The most common web server software in use is Apache, but you are also likely to encounter Microsoft Internet Information Server, Web Server. Apache can run on different operating systems such as Windows, Unix, or Linux. Microsoft Internet Information Server intended to run primarily on Windows Server. An application server, this software provides the building block for creating dynamic website and web-based application. Examples include the .NET framework from Microsoft and Java platform, Enterprise Edition. Also, while technically not considered an application server platform software that enables you to write application in language such as PHP, Python, and Perl also belong to the category. A web browser, Microsoft Internet Explorer, Mozilla's Firefox, Apple's Safari, and Google Chrome, and so forth. So web application component, already explained. Database server, web server, application server, web browser, and so forth. So you can see this slide, and then I already explained this one. And figure 7-3, a database enable intranet internet environment. As you can see, a bewildering collection of tools are available to use for web application development. Although Figure 73 gives an overview of the architecture required, there is no one right way to put together the component. Rather, there are many possible configurations using redundant tools. Open web technology within the same category can be used interchangeably. One tool may solve the same problem as well as another tool. However, the following are the most common combinations you will encounter. Internet information server, web server, SQL Server, Oracle as the database management server, and application written in ASP.NET. Apache Web Server, Oracle, IBM as the database management system, and application written using Java. The Linux operating system, Apache Web Server, a MySQL database, and application written in PHP, Python, or Perl. Also sometimes referred to as the LAMP stack. The network protocol for internet-bound traffic is TCP/IP, which stands for the Transmission Control Protocol. Internet protocol, the notion of the extranet, is what we usually think of when we use a website like Amazon. Companies interact with the public via extranet. An intranet also uses three-tier internet technology, web server, TCP/IP protocol, but is limited to access from within an organization control. This is hidden from the external internet by a firewall, providing security for the organization resources. Figure 7-5, information flow in a three-tier architecture. Figure 7-5A has no server-side processing, just a page return. Static page request. Figure 7-A presents a general overview of the information flow in a web application. A user submitting a web page request is unaware of whether the request being submitted is returning a static web page or a web page whose content is mixture of static information and dynamic information retrieved from the database. The data returned from the web server is always in a format that can be rendered by the browser. example HTML or XML. As shown in figure 7-5a, if the web server determines that the request from the client can be satisfied without passing the request on to the application server, it will process the request and return the appropriately formatted information to the client machine. This decision is most often based on the file suffix. For example, all.html and .htm file can be processed by the web server itself. And B has server-side processing, including database access, dynamic page request. However, if the request has suffix that require application server intervention, the information flow shown in figure 7-B is invoked. The application called the database management system as necessary using a special software called database-oriented middleware. Middleware is often referred to as the glue that holds together client-server application. It is terminology that is commonly used to describe any software component between the client and the relational database in NT architecture. Simply put, middleware is any of several classes of software that allow an application to interoperate with other software without requiring the user to understand and code the low-level operation required to achieve interoperability. The database-oriented middleware needed to connect an application to a database consists of two parts: an application programming interface API and the database driver to connect to specific type of database, example SQL Server or Oracle. The most common application programming interface are Open Database Connectivity, ODBC, and ADO.NET for the Microsoft platform, BV.NET, and C# and Java Database Connectivity, JDBC for use with Java program. However, no matter which application programming interface or language is used, the basic step for accessing a database from an application remain surprisingly similar. First, identify and register a database driver. Second, open a connection to a database. Third, execute a query against the database. Fourth, process the result of the query. Fifth, repeat step 3 to 4 as necessary. Sixth, close the connection to the database. The open database connectivity of application programming interface that provide a common language for application program to access SQL databases independent of particular database management subsystem that is exists. Application programming interface API set of routine that an application program uses to direct the performance of procedure by the computer's operating system. This figure shows the difference between static and dynamic page request. Any web request to a .html or .shtml file is static request. No application processing takes place on the application server. Basically, the file retrieved has all the HTML, CSS, and JavaScript code in it. URL with .jsp, .php, and .aspx, and dynamic page are dynamic page requests. Here, the application server is invoked and interact with the database to dynamically generate the HTML, CSS, and JavaScript that get sent to a browser. Yeah, I already explained the middleware and application programming interface common database API. So middleware is software that allows an application to interoperate with other software without requiring other user to understand and code low-level operation. Application programming interface routines that an application uses to track the performance of procedure by the computer operating system. Common database API, yeah. Open database connectivity, yeah. ADO.NET, yeah. And JDBC, yeah. Java database connectivity. Except for using database with middleware API, already explained, when you are writing a program that interact with the database, you will need to do all these steps in the code. Different programming language have different syntax, and we'll see a couple of example, others. So steps for using database via middleware API. First, identify and register database driver. Second, open a connectivity and connection to a database. Third, execute a query against the database. Fourth, process the result of the query. Fifth, repeat step 3 through 4 as necessary. Sixth, close the connection to the database. Figure 7-7 database access from a Java program. A Java implementation of database access to an Oracle database using Java database connectivity. Indicated previously, there are several suitable language and development tools available with which to create dynamic web page. One of the most popular language in use is Java Server Page. Java Server Page are a mixture of HTML and Java. The HTML part are used to display information on the browser. The Java part are used to process information sent from the HTML form. The code in figure 7-6 shows a sample Java server page application whose purpose is to capture user registration information and store the data in a database. Let us assume that the name of the page is registration.java server page. This Java server page perform the following function: display the registration form, processes a user's filled in form and check it for common error such as missing item and matching password field. If there is an error, redisplays an entire form with an error message in red. If there is no error, enter the user information into a database and send the user to a success screen. Let us examine the various pieces of the code to see how it accomplishes the above function. All Java code is found between the less than percentage and percentage greater than, and is not displayed in the browser. The only item displayed in the browser are the one included in HTML tag. It is worthwhile noting that both browser on personal computers and smartphone tablet are capable of displaying HTML. When a user accesses the registration.java server page in a browser by typing in a URL similar to HTML, myserver.mydomain.edu slash league app slash registration.jsp. The value of the message web parameter is null. Because the if condition fails, the HTML form is displayed without an error message. Notice that this form has a submit button and that the action value in the form indicate that the page that is going to process the data is also registration.jsp. After a user fills in the detail and click the submit button, the data are sent to the web server. The web server passes on the data called parameter to the application server, which in turn invokes the code in the page specified in the action parameter. Example, the registration.jsp page. This is code in the page that is closed in the less than percentage and percentage greater than and is written in Java. This code have several if-else statements for error checking purpose as well as a portion that contains the logic to store the user form data in a database. If any of the user integers are missing or if the password don't match, the Java code set the passage value to something other than null. At the end of the check, the original form of displayed, but now an error message in LED will be displayed at the top of the form because of the very first if statement. On the other hand, if the form has been filled correctly, the code segment for inserting the data into the database is executed. Notice that this code segment is very similar to the code we showed in the earlier Java example. After the user information is inserted into the database, JSP forward causes the application server to execute a new JSP page called success.jsp. Notice that the message that should be displayed by this page is the value that is in the message variable and is passed to it in the form of a web parameter. It is worthwhile to note that all JSP pages are actually compiled into Java servlet on the application server before execution. Java servlet is a Java program that is stored on the server and contains the business and database logic for a Java-based application. The segment of the application that are relevant from a database access perspective start with the try block. Let us examine them in more detail. The code shows that once the connection is made and stored in the con variable, the actual SQL query to be issued is constructed as a string variable name. Ins underbar query, the con that prepare statement and con that execute query commands are then used by the driver to issue the query to the database. In this case, insert a record. The con.commit statement asks the database to make this change parameter. See the section transaction interrupted later. After this, the connection to the database is closes. Notice how this step mirrors the general step for accessing a database identified in the previous section. Figure 7-7 shows the snippet of Java code that is retrieving data from the database using a SQL select statement. Notice that after connection is open, unlike the insert query shown above, running a SQL select query requires us to capture the data inside an object that can appropriately handle the tabular data return. Java database connectivity provides two key mechanisms for this: the result to set and load set object. The result to set object have a mechanism called the cursor that points to its current row of data. When the result to set object is first initialized, the cursor is positioned before the first row. This is why we need to first call the next method before retrieving data. The result to set object is used to loop through and process each row of data and retrieve the column value that we want to access. In this case, we access the value in the name column using the leg.getString method, which is a part of the Java database connectivity application programming interface. For example, of the common database type, there is a corresponding get and get set method that allows for retrieval and storage of data in the database. Table 7-1 provides some common example of SQL to Java mapping. Here's the Java code doing the step from the previous slide. The driver is the middleware program that provides the link to the database management system. At the open a connection step, you can see the connection string. And further down, you see the query. The data returned from the query is in a result to set, and your program can loop through this result set to obtain that data. The Java database connectivity classes that you will likely use in a Java database program are driver manager, connection statement, and result to set. Each of these are classes in the Java database connectivity application programming interface. Figure 7-A, system architecture of sample application. A Python web application. Python is a general purpose programming language created in the 1990s. After more than 2 decades of evolution and enhancement, it has now become one of the most widely used programming language. The most notable feature of Python are its elegant syntax and code readability. Python-based applications are cross-platform, that is, they run on all major computing platforms such as Mac OS X, Windows, Linux, and Unix. In recent years, Python has gained more traction and popularity than any other language in the developer community due to availability of many excellent frameworks such as Django, Flask, Pyramid, Tornado, Bartle, Diesel, Pecan, and Falcon, to name a few. These frameworks provide a collection of packages or modules that allows developers to write web applications or services without having to handle low-level detail. This example uses Django, which is a Python web framework. Figure 7-8 shows the system architecture for a 3-tier application built using Python. The third-party application that resides on the client is likely going to be HTML-based. The model view and serializer classes are written using Python and reside on the application server. The database resides on the database server. The figure also shows that the data exchange between view classes and the application are done using a standard format, in our case JavaScript object notation. JavaScript object notation, a data interchanging format that is both easy for human to read and for machine to parse and generate. So Python application for database processing. Model class create instances of data from table query. Serializer class transform database data into a form that can be used by the client. So client JavaScript object notation. So view classes display in browser for view or edit. So the database resides on the database server. The figure also shows that the data exchange between view class and the application are done using a standard format. In our case, JavaScript object notation. So already explained, JavaScript object notation is a data interchanging format that is both easy for human to read and for machine to parse and generate. Actually, this chapter will be 2-part. So we're gonna call it a day, Python, and then we will continue next video clip. Have a great day. And then we have to study more, because you understand this figure a little bit difficult. This figure shows Python application that invoke database server, various Python classes executing on an application server, and output to a web client. So we have to still in detail in next video clip. See you later. Bye.